stage. After the pour and cure, it's available for use. And here's a strap designed for use with wood frame construction. It's a one-time use device that is nailed in place over a double top plate, wrapped around, and nailed again. Simple and effective. As a general rule, the anchorage point should be directly above the worker and easy to reach. This is to make sure that if the worker falls, he or she doesn't swing like a pendulum and hit anything. The anchor point must be able to support 5,000 pounds per worker, or in unique situations, a professional engineer can design the system to withstand at least 2 times the possible impact load. Anchor points in non-engineered situations must be identified by a competent person who has been trained in fall protection systems and appropriate anchor points. All anchor points have to be regularly checked for weaknesses, deformity, cracks, and other signs that the points could fail. A convenient flexible anchoring device is the horizontal lifeline system. The line must be able to support 5,000 pounds per worker, or 2 times the possible impact load. The system should be designed by a professional engineer or a qualified person who can specify anchor points that won't fail if a worker falls. If you don't have a professional engineer to design a horizontal lifeline system, you can buy a system that will meet all the requirements when installed according to the manufacturer's directions. And like the anchor points, the horizontal lifeline systems must be regularly inspected. The new Subpart M doesn't cover scaffolds, ladders, or steel erection, but they are among the more common areas where construction workers often fall. In fact, over 60% of fatal falls in construction are from these 3 areas. Scaffold requirements are covered in Subpart L, ladders in Subpart X, and steel erection in Subpart R. More workers die in falls from scaffolds than from any other surface in the industry. The first choice for protection of workers on scaffolds are guardrails. If they can't be used, then provide the workers with a personal fall arrest system. The best practice is to attach the lanyard to a drop line, a rope grab, or an overhead anchor point. Employees have to be trained in the use, placement, and care of scaffolds. And a competent person must supervise the erection, movement, changes, and disassembly of scaffolds. When building scaffolds, erect them on firm ground. Make sure all braces, frames, base plates, and outriggers are secured. And install an access ladder, steps, or an equivalent safe access. When planking, make sure properly inspected and approved scaffold-grade planks are used to cover the entire working surface. Don't allow scaffolds to be overloaded. And have workers keep the working surface and access ladder free of debris, paint buildup, ice, and other slippery conditions.
And finally, the scaffold has to be regularly inspected. Another common hazard in the construction industry is the improper use of ladders. There are different kinds of ladders for different jobs. The 2 most widely used are the portable extension and step ladders. Workers should always carefully inspect their ladders for missing, damaged, or loose parts.
If the ladder is bent or damaged, it shouldn't be used. The ladder feet have to be on firm, level ground and not on slippery, uneven surfaces. And the work area around the ladder should be kept clear. When climbing, the worker has to face the ladder and center his or her body on the rungs. While working, the body should be centered on the ladder. The worker shouldn't overreach, lean to one side, or stand on one foot. This could cause a loss of balance or cause the ladder to tip. So the worker must always maintain a 3-point contact with the ladder. One of the most versatile and useful ladders is the extension ladder, but it must be set up and used correctly. The base of the extension ladder should be 1 foot out for every 4 feet of the ladder's working height. Before climbing to the working surface, the ladder has to be secured and extend 3 feet above the surface. This will allow workers to safely get to and from the working surface. Another popular ladder is the step ladder. When opening the step ladder, the spreaders have to be locked. Workers must climb up the working side of the step ladder. The highest safe standing level is the second step from the top. No one should stand above it.
And a closed step ladder must never be used as a straight ladder. It could slip out from under the workers. We also need to look at the hazards that come along with the erection of steel. Connecting steel is among the high-risk steel erection activities.
If placing members, tightening bolts, or installing purlins, employees must be trained to install and use fall protection systems. There are several conventional fall protection systems that you can use, such as safety nets, horizontal lifelines, and retractable lanyards. Workers might also choose to work from scissor lifts or man baskets. Since each construction project can be unique, the safety procedures and equipment must be pre-planned. For example, horizontal lifelines can be installed while the steel is still on the ground.
There may be situations and circumstances when you believe conventional fall protection systems are more hazardous, impractical, or infeasible to use. But OSHA believes conventional fall protection systems can be used in just about every situation, so it's up to you to prove and document that the conventional systems won't work. In these cases, you can use specialized systems such as the warning line, controlled access zone, safety monitor, and fall protection plan. Each of the systems has been designed for specific work situations, so be sure to look at the standard for the details of each plan or system.
A warning line is a barrier erected on a roof that warns workers that they are near an unprotected side or edge. It also designates the area where roofing work may be done without using nets, guardrails, or personal fall arrest systems. Warning line systems can be used for roofing work on roofs with a 412 pitch or less. On roofs steeper than this, you must use guardrails, nets, or personal fall protection systems. Controlled access zones are designated areas where work can be done without conventional fall protection. Leading edge, precast, and overhand bricklaying work can be done in these zones. If you use a controlled access zone, make sure the control lines restrict access to the zone and let workers know that only authorized personnel are allowed in the area. A safety monitor system can be used on low-slope roofs, outside of warning lines, or in a fall protection plan. It requires you to designate a competent person as the safety monitor. The monitor must warn employees of potential fall exposures and immediately do something to eliminate those hazards. The monitor is required to be on the same surface and to be able to see the other workers, and they have to be able to hear the monitor. The number of monitors depends on things such as the type of work being done and how close the workers are to the monitors. If the safety monitor system is all you're using, it has to be a part of a fall protection plan. A fall protection plan is the last resort for fall protection, including the specialized systems. It can be used for leading edge, precast, and residential construction work only. The plan must be prepared by a qualified person. It has to identify the areas where conventional fall protection systems, like guardrails, nets, and personal fall arrest equipment, will not work, and why they won't work. The plan must be site-specific, supervised by a competent person, include safety monitoring at a minimum, and include incident investigation procedures. A copy of the written plan and all its changes must be kept at the job site at all times.
We've talked about the fall hazards that exist on construction sites, the conventional fall protection systems, and the more specialized systems. Now, We need to look at what we have to do to tie it all together.
First, you need to identify the fall hazards. And once the hazards are identified, you have two options. You can engineer the hazard out, which means getting rid of it before the job even begins, or you can guard against it by installing guardrails around open-sided floors, covers over holes, or safety nets underneath bridge construction. You can also use personal fall arrest systems. But regardless of which system you use, you are required to develop a written program explaining how you will deal with each hazard. The program must list what equipment or system will be used and who will handle the supervising and training of workers. It also needs to include written proof that every worker has been trained in fall protection specifically for that job site. A rescue plan must also be part of the program. You have to make sure that rescue personnel, ladders, or other rescue equipment are available and that the rescue procedures have been practiced. If you use personal fall arrest equipment, it needs to be selected by a trained and experienced person. You are required to train workers in identifying the fall hazards and on using the equipment. They must be trained by a competent person who is qualified in the following areas: identifying fall hazards, the right way to erect, maintain, disassemble, and inspect fall protection systems, the proper use of all conventional and specialized fall protection systems, the limitations of those systems, proper storage and handling of safety equipment, what the employees are responsible for, and Subpart M.
In summary, it's very important for a contractor to remember these very basic points. Number one, manage this problem. Develop a formalized safety program that deals with falls from elevations. Number two, make falls from elevations a part of your new employee orientation. Number three, be sure you reinforce your fall protection program or fall management program through the use of your toolbox talks and safety meetings. And number four, enforce this program consistently and fairly on the job site.
If you would like to learn more about fall protection, here are two sources on the World Wide Web: OSHA at www.osha.gov and the Construction Safety Council at www.buildsafe.org.